Okay, hello everyone. Good morning. I think we should start. We're already 20 minutes late. So today we will talk about the Kafka performance optimization, how to automate that, and how to come up with the configuration. So today I'm Kalpesh. I'm lead engineer at the 1-2N. I'm mostly looking after cost optimization and the performance optimization. And Side by side, I play flute whenever I get time, and occasionally cycling as well. So when we say performance optimization of any system as a backend engineer, what exactly? So whenever we build any system, we build it at the configurable where anyone can set the configuration, and then as per the configuration, the system will run, or the service will execute the application using those configuration. And why is that? Because whenever or whatever environment we are using, that environment specific values needs to be set, and find to set those values of the configuration according to the where we are deployed the application. So you as a backend engineer cannot hard code those values, and hence because it is a environment specific, each environment is different. The Where you are deploy, how you are communicating with multiple services, that is different, and that's why we come up with the configurable sets. We build the configurable systems, and hence the Kafka is also the configurations. So Kafka having a lot of configurations to set. They have default configuration, but it is not necessarily that those default configuration will be work as expected as in your environment, because your environment is different environment. So to set those configuration variables, how do you know that what is the value of those configuration? How to get those values? How do you know that this is the value for this particular configuration works well for your environment? So that is most of the time challenging, and you cannot, or you will not get the actual performance with the default configuration all the time. So yeah, that is the background. Before going into the how we come up with the script and what we use, I want to give the system overview. So this is just the 0.001 just view of the existing system, where we have the topology, and it has 8 producers, let's say, and those producers are producing the messages at the rate of 1.2 million per minute. That is around 20k messages per second. So that is the load we are dealing with. There is a topic. In that topic we have 128 partitions, and then there is a consumer group where we have 128 consumers, obviously. So this is the setup where we are running the our load, or this is the this topology is basically processing, generating the messages, and then this consumer group is processing those messages as per the business rule. So this is overall setup we have. So when we say performance optimization, so basically these are the three things which we look after whenever we need to optimize the performance. That is, your throughput should, if it is a low throughput, then it is not the performance system. So you have to increase the throughput. If it is a high latency, then also it is not the very performant system. And if you are using inefficient storage, then also your system is not that performant. So basically these are the three areas where we should optimize the configuration or your system. So in specific to the Kafka world, so these are the three. So there are a lot of configuration, but to, as we highlighted, these three parameters which are important or bottlenecks for the performance. To optimize those, these are the parameters which are responsible to optimize that. That is linger.ms. This is basically the time duration where we can. This is the producer. All these three are the producer's configuration, where producer will decide when to send message to the broker. So in the overview, you can say that whenever we send message from topology to topic, so topic is basically at the broker level. So when you send the send command or send message from the producer, it will not immediately send that message to the broker immediately. It depends on these parameters. So it's a linger.ms. This time is basically, it will wait for that much time to send the message. Batch size is basically you will batch multiple messages into one round of communication with the broker, and compression type is basically what is the type of compression you are using to compress the message. Instead of sending, if you send message as it is, then it will not utilize the storage efficiently, right? So default values of these parameters are, so linger size is 0, that means whenever producer generates the message it will send immediately. And the batch size is default 16 kb. Whenever your batch of so again, when I say 0, as it is not immediate, again it will try to batch out in that scenario as well, because it's a millisecond, right? So in that scenario also it will try to batch the messages into maximum to the batch.size value. So it's a 16 kb, and default compression type is none, where it will send message without compression. So with this configuration, obviously you will not get the performance. But what will then, when we say linger.ms value is 0, what should be the value in my environment? It is an environment specific, right? So to come up with that value, you have to generate the load to your system. Let's say uh, in your production, this is the configuration. So that with that configuration, we replicate that or simulate the same environment to test or to benchmark the system. So what we did, we utilized the, so Kafka come up with these multiple utilities. One of them is the Kafka-producer-perf-test. Using this utility, we can generate the message with the, let's say there are how many messages we have to generate, what will be the average size of the message. So all those parameters we can pass to this script, and it will generate the load. But now this is just the producer, but what about configuration? What should be the configuration when I generate that load, right? So we created one script. That script is basically in that script we have for loop kind of, where in that for loop I am running this script multiple times with different configuration, and that configuration is basically I will show you that in the demo itself. Yeah. So first I will just run the demo, and then I will show you the script. Okay, so for this setup, we have created the docker.compose, where again, as a developer, we always start with the local first setup, right? So we created the Zookeeper container, then Kafka container, and the Kafka UI container to just look at the UI of the Kafka, where how many messages are there or what are the topics we have. So these three containers are running. Let me show you the UI as well. So this is Kafka UI, where we don't have any topic at the moment. So this is the script where we increase the font. Is it visible? Okay. So in this script, I am creating topic and running the producer test and the consumer test. So let me run that test. So this script is basically creating the topic with 128 partitions, and then it will start producing the load with the this configuration, whatever configuration we have here. It will take some time. Till that time I can walk through. So in the configuration folder, I have created multiple configuration. And why it is that? Because now in this configuration, I can set, so this is the default configuration where batch size is 16 kb, linger size is 0, and the configuration is none. So it will produce load with this configuration. In next loop, next iteration, it will load this configuration and then generate the load. So in that configuration, we have set the batch size as 65 kb, linger size as a 10 millisecond, and compression type as a LZ4. So there are 3 to 4 compression types are available: LZ4, ZZip, and Snappy. Where ZZip is CPU intensive, it will take a lot of CPU. So that hence, and again, we don't know that in our environment. So you can have that configuration as well, where you can change this. You can have 10 producer or 10 properties of configuration, where you check the what exactly ZZip is working or how it is performing in your system. So we tried with all these multiple combinations, where changing batch size and then linger size and the compression type. Yeah, so this is done. So this local setup is just to make sure that whatever script I have created, it is working fine or not. That is the only purpose, because I cannot match the whatever setup I have in the production or in the staging. I cannot mimic that on my system. So whatever results it generates, we cannot use these results. So, but at least it will give you that confidence that this script, if you run this script in that environment, it will give you these numbers. So again, for this producer one configuration, it took around 6 round trips. So again, this script is generating the message, whatever size you have given to it, and then it will try to send those many messages based on the configuration. So it is the overall throughput. If you look at it, is around 38,000 records per second. It is sending those many records. Okay, and then for producer 2, if you look at that, it is taking only 4 rounds of communication with the broker, and in one round it is sending 58 or 55,000 records per second. So at my local machine, this configuration is much better than the default one, right? So this is how we come up with this script, where it will run the producer test. And it is nothing but that same script which was provided by Kafka, and we are sending that throughput, how many records I have to send, the message. And again, message size is whatever message, average message size you have. Generally you must have some observability metric where you know that what is the average size of your message. So that message size you can set here. The only drawback of this script is you cannot send the custom messages. Right now I am just providing the size of the message. That means internally this script generating that many bytes of the string. So it's a random string. But in real world, it is a JSON. So unfortunately we are using JSON. Not sure why, but it is from legacy. You should not use JSON, because it's again you are sending repeated values over and over in the all messages, right? Because keys are duplicate. Keys are not changing in each message. So you are sending those messages, those values repeatedly in each message. So but yeah, but that is again that's where the compression plays a very important role, where if you have multiple values which are repeated in all messages, then it will compress a lot, right? So yeah, this is producer, it will generate the load and then we get these results. So we run this script into the environment, in the staging environment, and got these numbers. And from that we identified that what is the suitable configuration values for our environment. So those values we used, and again, as I said, we didn't send the actual messages, whatever messages we have in our system. It was just a random string. The compression rate was not great in this benchmarking results, because it's a random string, and hence the compression ratio of those messages are very low as compared to the or original one. So we tried top. So after this test, we got the configuration wise numbers, and from ascending order or from descending order, we chose that what are the best 3 configurations we have. So then we run those 3 configuration manually into actual system, because as I said, the compression was, we need to check actual compression with the actual messages. So we run those and then finalize the what is the suitable configuration in our system. So that's how we get the numbers for those configuration. If I refresh this, so this, it created these 2 topics and then 1 million messages per topic. So that's how. we generate the load. Any questions so far? Yeah. Again, in your system, these are the two sides. It's producer and the consumer. Consumer is if it is not producer, not that great or not able to consume those many messages. That is the configuration. Again, the same configuration we have for the producer, you have configuration for the consumer as well. But our problem was more at the producer side, not at the consumer side, because if we are not able to generate the load, then we don't know the capacity of the consumer. So first you have to fix the producer and then the consumer, right? Again, it depends on your requirement, right? If you said that as a one only, then that means you will get the acknowledgement whenever any one of the broker acknowledge that message. That is system sensitive, correct. It is depending on the system. What if your system is if you want your system reliable, then you cannot go with the acknowledgement value with one, right? What if that node got crashed, you lost that message, you know? So it is domain dependent, it is system dependent, and hence those values, those configuration values are come because that's what I said in the beginning itself, where these configurations are your environment specific and your use specifics, and that's why those are configurations. Yeah. So linger.ms is where default value is 0, right? And now we say change that value to 10 milliseconds. So that means whenever producer producing message, it will not send those messages immediately. It will wait for 10 milliseconds. Yes, yes. So these are the two. Whoever trigger first, it will send the message. So let's say in 6 millisecond. No, no, no. No, 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 no. It is any one of them. Whoever fulfill the requirement first, it will send the message. So let's say in 6 milliseconds itself, you full the batch, then it will send the message. Correct, correct. So compression, again, you are adding the extra overhead in the compression as well. But once you have that, that is one time job at this producer level. But at the consumer level, again, so it is going to decompress that message as well. But the volume you are sending in that batch is very high, and hence this value or this time required for compression and decompression is negligible. Hmm. Yes, yes. So anyway, it uses batches. So even though your, as I said, the batch size is default batch size is 16 KB, right? So it will doing batching internally as well. So it is not necessary that if linger size is 0, then it is not going to send that message immediately. It will still try to batch. Let's say maybe it's a value 0, then it try to compress two or batch two messages, but it is going to try for batch for sure. But if you increase the size of the batch and the linger size a lot, then definitely those messages will be in your local or in memory, and if that container got crashed, then you will lose those messages. So hence that, and that's why it is the environment specific and your requirement specific, and those value, and that's why this script can help you to come up with these values, those parameters values as per your environment. So that was the one, and that's why I keep only two configuration. I removed all the middle configuration. So this is none, and this was the one which worked for us very well with compression type LZ, and batch size is 65 KB, and the linger size is 10 milliseconds. Yes, yes. So I will show you those numbers. So earlier it increases the throughput by 245%. Earlier it was able to send around 606K messages per second, but now it is sending more than 20K messages per second. Latency got improved by 90%. Earlier it was taking around 25 milliseconds to send the messages, but now it is taking 2 milliseconds. And the storage wise, earlier it was no compression, so it was after compression it is using only 11% of the storage. So we improved the storage by 89%. These are Kafka producer graphs. I mean, if you look at these numbers, these are Kafka.producer per request. It will give you the request. I'm not sure whether this value is visible to you or not. Yeah, this is Datadog. This is the request latency message, and this is the compression rate average. What is the Mhm. Mhm. So these, for these configuration specific changes, again it is your producer where you must have already have those exception handling and all, but it is not due to the configuration where you will lose the messages. I mean, based on obviously if the batch size is high and then the linger size is higher, then it will increase the probability of getting crashing or deleting that particular container. It will, you will might lose those messages. But in our system we have the recon in place where if the end status of that particular message is not the terminal state, then we have the recon system which will ingest that message again into the system. So we, in this particular case, we haven't changed any configuration for the consumer. We just increase the throughput or increase the performance of the producer. This, I mean, till this point. But for consumer, again, the same script we have, right? Where you can provide those configuration as well. So, but in consumer, there are other set of configuration, which is again another talk might be, because those values are different. I mean, yeah. Correct, correct. So for producer, it is just the acknowledgement. Once you get the acknowledgement, then that's fine. Yeah. Yes, yes, same message. Again, it depends on your system. If you are sending message again, or maybe let's say it might be possible that because of certain conditions, messages who are already delivered, but you are ingesting that again. So your system should be idempotent enough to handle that those cases as well. But that is at the consumer side. Yeah. Yeah, yeah. So the partition wise, we tested that for 128 partition, right? So the acknowledgement value was 3 in our case, where if we that message got sent to 3 replicas, then we are good. Yes, yes. Correct, correct. Yeah, yeah. Internally, it retries those messages. Yeah, that's why in earlier question I said that those values are very negligible in as compared to the latencies we improved. Mhm. Mhm. Again, it depends on your type. If it's a JSON, and then it will be Snappy is the best one, but unfortunately we couldn't use the Snappy due to the that was not available in the system. We were using 2.4 version, and hence so this setup is the on-premises setup, and we haven't installed that library. For Snappy, you have to install that separately. LZ4, gzip are inbuilt; those are come up inbuilt compressions, but and then providing that support or installing that library, it is a big process. It's an enterprise client where that process is very longer. So even these, after getting these numbers, to get these numbers on the production, it took 3 months because of the enterprise environment and all. So mhm. Correct, it will send that. Yes, yes. So on an average, our message size was 5 KB. Yes, yes. Yes, yes. So again, this script, if you run this script with your configuration, it will give you those numbers. What should be the batch size? What should be? Yes, yes, yes. Correct, correct. That's what I said. So these numbers are, as I said, that script generating the string on the fly. It is not using the real messages, right? So the compression is not as actual as in your for your message, right? So you have to again try out those whatever top 3 or 5 configuration you got from this script. You have to try out those independently, separately. Hmm. Yes, yes, because of the crashing. Yes, yes, failure. Yes, yes. Correct. Yes, yes. Yeah, it is again not only the throughput and latency, right? It is use case as well. If you cannot, if you that configuration gives that 1 minute linger time is giving you a lot of throughput, but it is not going to work. You cannot wait the transaction for 1 minute, right? So that business use case you have to consider. It's none. It is not going to compress. It will send message as it is without compressing. Okay. Anything else? Okay. Thank you then.